Solving inequalities is just like solving equations. You want to get the x by itself on the left. So in this first case we would be subtracting 5 on each side. And that would give us x is greater than or equal to 6. Now that would be the solution if we were just writing it as an inequality. If we were asked to graph this on a number line, we would include the number 6 and shade everything to the right and shade in that number line or that arrow on the right. And if we were asked to write this in interval notation, we would say from 6 to positive infinity inclusive of the 6 on the left. And sometimes we even write x is an element of. That little squiggly e is the Greek letter epsilon, and it stands for, is an element of, or is a subset of, or x is contained within this set. When we are solving this inequality, we are saying any number greater than 6 will work in or satisfy this inequality. 15, for example, is a solution, and 15 plus 5 is greater than or equal to 11. And remember, we're not just dealing with the whole numbers 7, 8, 9, 10. We're dealing with all sorts of irrational numbers like the square root of 82, which is a little bit more than 9. That would be our solution to this inequality also. Okay, let's move on to the next one, a two-stepper. We're going to begin by adding 7 to both sides. That will give us 3x is less than 26. And then dividing each side by 3, we will find that x is less than 26 thirds. That is perfectly fine if we're just leaving our answer in an inequality form. However, if we were to be writing this or graphing it on the number line, we would graph 26 thirds, leave it an open circle, and shade everything to the left of it, representing the less than. And by the way, notice how the shading to the left matches this, what might appear to be an arrow going to the left. That works whenever the x is by itself on the left. In interval notation, we would say x is contained in this interval going from negative infinity on up to 26 thirds, which we will not include, represented by the closed parentheses as opposed to a bracket. Okay, here we go. A few more of these. Now, there is an exception to the rule, and that is whenever you multiply or divide each side by a negative, then you change the direction of the inequality. So in this problem C, we would subtract 5 on each side. That would stay negative 2x less than or equal to 12. But in the act or process of dividing each side by negative 2, it's the division by a negative that will have us reversing the direction of this inequality and have us writing x is greater than or equal to negative 6. And then on the number line here, solid dot at negative 6, shade everything to the right, including the number line. In interval notation, we are saying negative 6 included up to positive infinity. And if you wanted to partially check this, you could choose a number greater than negative 6. Let's choose 2, for example. 5 minus 2 times 2. 5 minus 4, that would be 1 on the left, is less than or equal to 17. 1 is less than 17. That is a true statement. We could choose something like negative 10 and find out that it doesn't work. When you substitute negative 10 in, you have negative 2 times negative 10, which becomes plus 20. 5 plus 20 is 25, which is not less than or equal to 17. And since negative 10 is not, it is not part of the solution set, and therefore there should not be shading on the right, on the left-hand side there. So everything is consistent. In problem D, we have a compound inequality. In this case, we want to solve for x in the middle between the two inequalities. added 7 to the left and the middle and the right, and we will have negative 10 is less than 2x, which in turn is less than or equal to 22. We want an x by itself in the middle. We want to divide off the 2. Dividing by a positive 2 does not change the direction of the inequalities. It's only when we divide by a negative. So we're going to have negative 5 is less than x is less than or equal to 11. And that would be our compound inequality solution. On the number line, we would have the critical values at negative 5 and 11. Open circle on that left, closed in circle on the right, shaded in between. In interval notation, we would say x is contained in this interval from negative 5 to 11, inclusive of the 11 on the right-hand endpoint. On this next problem, we see negative 5 times x. We want to divide by negative 5. It's the multiplying or dividing by a negative on each side of the inequality that change this from a less than to a greater than. So x greater than negative 6 is our answer in an inequality form. On a graph, it would be an open circle at negative 6, shade everything to the right, and in interval notation, it would be from negative 6, which we do not include, on up to positive infinity. And I don't think you need a lot of examples here because I've shown you the only exception to the rule, and if you've already spent a bunch of time learning how to solve equations, learning to solve the inequalities is no extra feat to tackle.